Hello guys, today we will derive the formula of an equilateral triangle, area of an equilateral triangle. So here I have an equilateral triangle ABC, triangle ABC, and AD can be considered as the height of the triangle, right? We know what the formula of the right angle, what the formula of the equilateral triangle. We know the formula of the area of a triangle, which is half into the base into the height. Right now we don't know the base, neither do we know the height. So just for understanding, let's give this a variable. Let's give the base BC a variable as A. Right? Okay, I'll just give out some space for this part. So we gave the variable for B, which is A. So half into B can be written as A. Half into B can be written as A by 2 in this case into the height. So right, we got it till here, but we don't know what's the value of AD. To do that, we know that the height is always perpendicular to the base, which makes the triangle ADC a right angle triangle. And what works to find the hypotenuse or any of these sides if you have two of them given, two of the values? So the answer will be the Pythagoras or the Bodhayana theorem. So let's leave this part aside and let's find out what is going to be AD. We know AD square, which is height square, added with DC square. Now we don't know what's the value of DC, but we know that DC is half of BC because it is dividing the base into two equal halves. So DC is equal to BC by 2. We know what BC is. BC is A. So DC will be A by 2. So A by 2 whole square, which is DC whole square, right, is equal to this. Now AC, as I told you, equilateral triangles have all angles and all sides equal. That is, all angles are 60 and all sides are equal. We'll check on that. It actually varies. Only the angles are constant. The sides will vary. But coming back to the topic, AC is equal to BC is equal to AB. So the variable we assigned for A will work for all of these sides, right? So we'll give the variable A to all of them. We can give them A1, A2, A3, whatever. Simply let's just give A because here we have the same variable. So we'll write A square. And now we'll substitute. So I'll just cut everything on this slide and we'll continue. So height square plus A by 2 whole square can be written as A square by 4 is equal to A square. Now height is a value. It's a constant variable, whatever you want to call it. So we won't take this to the other side, but we rather want to take this so that you can subtract it simply. So height square can be written as A square minus A square by 4. Right, so to make them like denominators, I'll multiply this A square with 4. So we'll be getting the answer is 4A square by 4. 4A square by 4 minus A square by 4 can be written as 3A square by 4. So H square is equal to 3A square by 4. Take the square to the other side. So you're going to get height as root 3 A by 2. Right. So I'll cut everything again. Now we know the height, we know the base. So half into base, which is A, into the height, which is root 3 A by 2. Right, so you multiply these A's, you will get A square No, because when you multiply root 3 with 1, it remains the same. So you'll be getting root 3, right? And when you multiply 2 and 2, you get 4. So root 3 by 4 a square, or root 3a square by 4 is the area of a equilateral triangle. I'll just write it for reference, equilateral triangle.